Day 3, polynomials we're going to focus on. So we got, first thing we're talking about is how to use the binomial form of x minus a. So how to use your long division or synthetic. Make sure you put a 0 if the term does not include the original polynomial. So we're still going to focus on synthetic. I think I'm going to wait till more people here if we want to talk about long division a little bit. But when you're doing, when you're dividing 4x cubed minus 13x plus 9 by x plus 2, we'll stay with synthetic since that's the concept that we focused on. You have negative 2 is the 0. 4 is your first term. There's no x squared. We have to account for that with a 0. We have negative 13 is our x, and then 9 is our constant. And now we can synthetically divide from there. Remember, to start, you drop the 4 and you multiply by the negative 2. Negative 2 times 4 is negative 8. Add negative 8. Negative 2 times that is 16. Get negative 3. Positive 3. Thanks. Oh, no. That's all right. Okay, so we got this. Negative 8. Positive 16, like Fo just said. 3. And then we have negative 6. So we get 3 is our remainder. Okay, remember that weird way they like you to write it? They like to write it as your divisor plus your remainder. Okay, so you do the p of x is equal to the divisor times the quotient plus the remainder. That's how you write it, and that's how they asked for you to do it in the book. There was one of those that was similar on one of your exams. So in this case, the divisor is x plus 2. The quotient is this part down here, which is 4x squared minus 8x plus 3. And then plus the remainder, which is 3. So that's how you'd write that. Okay, any questions on that? Right. It'd just be, yeah, or it would just simply be, yeah, you would just, that's fine actually, yeah, it'd be good. Okay. All right, so then if we go further here, we're using remainder factor theorems to factor polynomials. So how to use x minus a as a factor that remainders is 0. So it says determine the value of k in p of x if p of 1 is 0. So it's telling you is this is where you have subsynthetic and you have to solve for the missing variable because it's telling you a 0. This means to you that when you plug 1 in, you get a 0. So then we know that if I put 1 here, okay, it's going to be 8k negative 11, negative 3, and I know I should get a 0 here. And so we're going to work through this with the k involved until we get to a point where we can solve for k. So we get this, we get k plus 8, then we get k plus 8 minus 11, so k minus 3. Then we have k minus 3. If you add those, it'd be k minus 6 equals 0. Okay, see that? And so then simply k is 6, right? That's all we need for that. Okay, any questions on that one? Okay. All right, so how to fully factor. Graph your calculator, determine the x-intercepts. There are your factors. Determine the multiplicity of your zeros by looking at the shape of the graph of the zeros. The sum multiplicities will equal the degree of your polynomial. To fully factor algebraically, choose factors of your constant, okay, and sub them into the polynomial to get results. So this is kind of just walking you through how you can determine the roots and the exact values of a polynomial that's maybe a little bit uglier, a little bit harder. The thing you have to remember is I do want you to know your possible zeros are factors of the constant over factors of the leading coefficient, right? And so your factors of the constant there is plus or minus 9, plus or minus 3, plus or minus 1, over plus or minus 5, plus or minus 1. Those are your possible factors. So 9 over 5 is 3 over 5, 3 over 1. Those are all possible factors. It cannot be 9, no. Wait, can it be 9? Yeah, it can be 9, 9 over 1. Yeah, that's a possible factor. But it's not automatically 9. So yeah. Okay. So then where this is talking to the top here is that you can look at your calculator. You can put your calculator, might as well, and you can get an idea of what to try. because obviously there's let's see, 3, 2, so there's like almost, let's see, oh, sorry, 2, there's like, gosh, how 2, 6. Yeah, I'm just saying there's like a combination of, there's like about 12 combinations, okay, of possible answers, okay? I'm trying not to double count. But anyway, so when we're doing this though, if you go ahead and you look, we can think about the possible zeros, and we can think about, okay, we put in our calculator, we might look and see that, in this case, I'll kind of cut to the chase. If you look and see, you'll see that there's a 1 that looks close. Like 1 looks like a 0. So if 1 looks like a 0, then you want to go ahead and synthetically divide that out and see if you get a remainder or not. So if we try 1, we get 5, negative 51, 55, and negative 9. So drop the 5. Okay, we get 5, negative 46, negative 46, 9, 9, 0. So 1 is a 0. So that's good. So that means a factor is x minus 1 though, right? X minus 1 is a factor. So now we have it in x squared form. Here you should be more comfortable. Okay, here you should be more comfortable because this is 5x squared minus 46x plus 9. Now, of course, you can still use your calculator and you can see if there's anything close. But you can factor that possibly, right? So try to factor it first. This one is factorable. 5 times 9 is 45. Factors of 45 that get you 46 is negative 45, negative 1. Like that. And when you factor that out, you're going to take a 5x out and a negative 1 out. It's going to give you 5x minus 9 and x minus, 5 comes out, that's a negative 9. And I take a negative 1 out. Sorry, it's 5x minus 1, x minus 9. Okay. A couple things to look at in terms of just to check your work. So from the original, see my 3 constants in the end? Negative 1, negative 1, negative 9. 3 negatives, so the end should be what? Negative. So 1 times a 1 times a 9 gets me 9. Should be a 9. My answers, I got 1 for my, that's a 0, 1/5, and 9, right? Are those all possibilities for my possible zeros? I have 1 here. I have 1/5 is possible, yep. And I have 9 over 1. So yes, all those are possible zeros from our possible zero set. Okay. And pretty much other than that, that's all the things I would kind of check out to make sure that I'm good. Okay. Just since this one didn't go over it, we might go over here in a second. Yeah, we're going over next. Sorry, I'll wait. I was just talking about multiplicity, so that's coming next. All right. Any other questions on that one? You 4, no? Okay. And yeah. (5x minus 1). Well, I just went ahead and did this. When you pull a 5x out, and then you pull a negative 1 out of this one. So 5x came out of this guy, and negative 1 came out of this guy. So 5x minus 1, and then x minus 9 is left. Yeah, I just skipped the last part of the factoring because of room, sorry. Okay. All right, and there we go. So our last full page, and we got a little piece, and then we're done. Okay, so it says sketch a graph polynomial function. Again, so determine the multiplicities of each zero. That's the shape of the graph of each zero. So remember, if it's a multiplicity of 1, that means it goes straight through, like straight through. If it's a multiplicity of 2, it bounces. If it's a multiplicity of 3 or higher odd, it twists through. Okay, so point of inflection, remember? Determine the y-intercept, degree and sign, etc. So let's write some couple notes here. Even degree and leading coefficient. Okay, so even degree, leading coefficient. This is talking about leading coefficient's positive, and it's an even degree. So what is that graph behavior going to look like? So if it's even degree, that's kind of like a parabola, right? So we know if it's even degree parabola, that parabolas, they go this way and they go this way at the end. We're talking about the end behavior. So that works. If I have a 6x squared and a bunch of stuff, it's going to start high, end high. Okay? If I have an even degree with a negative, it's going to do what? start low and low. Good. It's going to go here, here. Odd degree leading coefficient positive. Nope. Backwards, other way. Yeah, because odd degree with a positive leading coefficient, so the way I think about it, Lauren, is that negative numbers to the odd power are what? Right, it's like what's negative 2 to the cubed? Negative 8, so it's still down here. See what I'm saying? And then it finishes here. Because then like positive 2 cubes, 8. So negative 2 cubes, negative 8, positive 2 is cube is positive 8, so it starts low, ends high. And then what happens is if you just switch the coefficient, it just flips what you're doing. Now that negative 8 and negative 2 would make it go this way. Sorry, I don't want to draw it like that. Even though that's the direction it's going, but it's ending this way, like that. Okay, and we're doing that one that we did on a couple of our exams. Sketch the graph that satisfies the negative leading coefficient. 1, 0, multiplicity of 1, 1, 0, multiplicity of 2, 2 zeros of multiplicity 3. Okay, so we'll go ahead and do that. You can sketch yours, and I'll sketch mine, and then we'll talk about it. They can be different. They're not going to be exactly the same. All right, so negative leading coefficient. So multiplicity of 1, 2, so like, just so you know, if I have 1, 0, multiplicity of 1, so that's 1, 0. I have 1, 0, multiplicity of 2, so like I'm thinking about my exponents. This is 2 zeros of multiplicity of 3. So I have 6, 8, 9. So this is like a 9 degree. It's like a 9 degree. Yeah. So that means that if it's, the reason I want to figure that out is because if it's 9 degree, then I know that it's going to end opposite. It'll end high and low, or end low and high, right? So let's just go ahead, just anywhere is fine to. Okay, let's go ahead and I'll put 1 here. 1, 0, multiplicity of 1. We got 1, 0, multiplicity of 2. 2 zeros of multiplicity of 3. So let's just go ahead and try to do it here. Okay, so it's a negative leading coefficient. So if it's negative leading coefficient and 9, that means it's negative and odd. So that means it's going to start high and low, right? From your pictures, it's right here. It's this one. And what makes sense is when you actually draw through these zeros, you don't have to do them in order. I'm just doing them in order. But when you draw them, it'll force you to end that way. Okay, so like watch. 1, 0, multiplicity of 1. What's multiplicity of 1 do? Straight through. Okay, and then multiplicity of 2 bounces. Okay, multiplicity of 3 changes inflection. Okay, like that. That's what it'd look like-ish. That's just an example of one. And so these right here, I know they're not Greeks, and you know, these are points of inflection. So I try to show they're rounded. Change of, you get the inflection point there. We got their bounce point there. Okay. All right, just a second. Good. All right, one more here. Okay, so find the leading coefficient of polynomial functions. So this is one that a lot of us missed in the exam. I remember we forgot a couple things, but it says how to determine the factored form in place of a stretched factor of a in front of factors using a given point to substitute for x and y to solve for a. So it says determine the equation of the factored form of a 4th degree polynomial function which passes through 1, negative 12, is tangent to the x-axis at 2, 0, negative 3, 0. What does tangent mean? Bounce. Good. So that's your 4 degree, right? So that means that x minus 2 is squared and x plus 3 is squared. And so that's all you need. Because now you have exactly what it's going to be, except for I have to have a constant there to make 1, negative 12 true. So what you do is you plug in the 1 here. Like we don't know what a is. So we put an a here. We put 1 in for x, and we put negative 12 for y, and then we solve for a. Okay, so if I put 1 in, 1 minus 2 is negative 1. Negative 1 squared is just 1. So So that's going to be 1 there. Put in 1 here. 1 plus 3 is 4. 4 squared, 16. It's supposed to be negative 12. So that means that A, divide 16 is negative 3/4. So A is negative 3/4 for this example. And so then your final equation, P of x or y equals is minus 2 squared and plus 3 squared. Okay. And that is it.